Let us look at the next question, that is question number 12. The number of arrangements of A1, A2, A3, etc., A10 in a line so that A1 is always above A2, ahead of A2. That is, A1 comes before A2 comes. Like that. How many such arrangements are possible? The first option, that is option A, is 2 into 10 factorial. The second option is half into 10 factorial. The third option is 10p2. The fourth option is 10c2. It can be answered with the most general understanding. Let us first assume there are just 3 numbers, rather 3 things there. How many ways can you arrange them in a row? ABC, ACB, BCA, BAC, CBA, CAB. Suppose we have put some restriction on one particular letter to lie ahead of or behind of. Let us assume that A comes before B. Observe in what arrangements it will happen. A comes before B, A comes before B, A comes before B. In exactly half of the total arrangements, A comes before B. Not only A and B, you can put the similar type of restriction for any pair of elements, say B and C. You observe, exactly half of the arrangements contain B before C. Similarly, half of the arrangements contain C before A. Like this, not only for 3 elements, for any number of elements it happens. There are 10 elements here, of course, in the present problem, and in the required arrangements, he wishes us to have A1 always to come above A2. So the restriction is put for A1 and A2. As in the previous discussion, we can say that the total number of arrangements is half of the total arrangements. How many things are there? 10. Total arrangements, 10 factorial. Half of that is half into 10 factorial. A is the right option. What is the right option? Second option, that is option B, is the right option. The right answer is half into 10 factorial. The next question before us is question number 13. Let us see the question first. A student is to answer 10 out of 13 questions in an examination, such that he must choose at least 4 from the first 5 questions, and the number of choices is available to him is number one, that is option A 140, option B 196, option C 280, option D 346. Those are the given options. Let us follow the question carefully. In total, how many questions are there in the question paper? 13 questions are there. Out of 13, how many questions he has to answer? 10 questions out of 13 he has to answer. Is there any restriction? As there is a restriction. What is that restriction? He is supposed to choose at least 4 from the first 5 questions. Let us observe the different possible cases here. From the first 5, altogether there are 13 questions from the first 5, and from the remaining 8. Here, only 2 cases arise. He may choose exactly 4 questions, and in total he is supposed to answer 10 questions. So in this case he has to choose 6 questions from the remaining 8 questions. This is one case. And in the second case, he may choose all the 5 questions here. Still he is supposed to answer 5 more questions from the remaining 8 questions. Yes, these are the possible cases. Here, what is the total number of ways? 4 questions from 5. 5C4. 6 questions from 8 questions. 8C6. So So the total number of choices for him in the first case is 5C4 into 8C6. Okay, again in the second case, if he chooses 5 questions out of 5 in the first fry, then it is 5C5. And remaining 5 questions from the remaining 8 questions, he can choose in 8C5 ways. Altogether, what is the total number of arrangements? 5C4 is 5, 8C6 is 8C2, 8C2 is 8 into 7 by 2 factorial, that is 28. 5 into 28 is 140. And again here 5C5 is 1, 8C5 is nothing but 8C3 is 56. There it was 140 and this is 56. All together this is 196. The total number of choices possible to him to answer 10 out of those 13 questions with the given restriction is found to be 196, and it is readily available in the second option, that is option B is the right option. Question number 13, answer is 196, that is option B. The next question, that is question number 14. In a polygon, no 3 diagonals are concurrent. If the total number of points of intersection of diagonals interior to the polygon be 70, then the number of diagonals of the polygon is. Number of diagonals of the polygon is. To answer this question, you must have a perfect command over the awareness of number of diagonals and the points of intersection that can be formed internally inside the polygon about the diagonals. Yes, abide by. What are the given options? The first option is 20, second option is 28, third option is 8, and fourth option is 36. Let us see. In a polygon, no 3 diagonals are concurrent. Well, let n be the number of vertices. The total number of points of intersection of the diagonals interior to the polygon to be 70. What is that 70? With what quantity we are supposed to equate that 70? Let us understand carefully. See, there are n vertices of the polygon, and to have a point of intersection of the diagonals, you are supposed to choose 4 vertices. If you are able to choose 4 vertices, automatically a quadrilateral will be formed, and for that quadrilateral, definitely point of intersection of diagonals will be there. So, if you choose 4 vertices, one point of intersection of the diagonals is going to be observed. Like that, what is the total number of points of intersection of the diagonals? The number of ways in which you can choose 4 vertices out of n. That's all. Therefore, what is the total number of points of intersection of the diagonals? NC4. Why is it to be NC4? To have a point of intersection of the diagonals internally, you have to choose 4 points, 4 vertices. Therefore, the number of ways of choosing is NC4, and you are supposed to use it for 70. NC4 is equal to 70. NC4 is equal to 70. Right? You know that 8C4 is equal to 70. You can calculate if you want. 8 into 7 into 6 into 5 by 24, it is 70. By this comparison, you will be able to have n is equal to 8. N is equal to 8. That is, it is the polygon given is an octagon. The number of sides here, it is 8. Okay, what is the question? Do you want to have the number of sides or number of vertices or number of diagonals? Number of diagonals we must have. Yes, there are n vertices, that is n sides. What do you mean by a diagonal? What is meant by a diagonal? A diagonal is nothing but a straight line joining any 2 vertices different from the sides. Therefore, number of diagonals is therefore number of diagonals is equal to total number of straight lines using these n vertices minus number of sides. This can also be taken as n into n minus 3 by 2, and you take n is equal to 8. This is nothing but 8 into 8 minus 3 by 2. 8 minus 3 is 5, 8 5 is 40, 40 by 2 is of course 20. So what is the total number of diagonals present here? It is 20 and it is available in option A. So the right answer is 20. That is right option is option A. Question number 15. Let there be 9 fixed points on the circumference of a circle. Each of these points is joined to every one of the remaining 8 points by straight line, and the points are so positioned on the circumference that at most two straight lines meet in an interior point of the circle. The number of such interior intersection points is, if you can follow the sentence given in the question carefully, it is an easy matter to understand that the number of points required is just nothing but the number of points of intersection of the diagonals. Yes, of course. 9 sides because there are 9 points. If you can choose 4 points at a time from those 9 points, for any set of those 4 points, a quadrilateral will be formed, and for each such quadrilateral, a point of intersection of the diagonals can be observed. Of course, those points are required now. They are interior points of the circles. Therefore, the total number of such points is just nothing but 9C4, because it is equal to the number of ways of selecting 4 points from the 9 points available. So it is 9C4, and 9C4, if you can calculate that, it becomes 126. Therefore, what is the right option? Option A is the right option. So the number of interior points of intersection which lie inside the circle are nothing but the number of points of intersection of the diagonals, and it is equal to 9C4, which is 126. The next question before us is question number 16. In this question, he is asking us the sum of the integers lying between 1 and 100 that are divisible by 3 or 5 or 7. Let us first name the set of all those integers which are divisible by 3 by the set A, and the set of all those integers which are divisible by 5 by the set B, and the set of all those integers which are divisible by 7 by the set C. Now we want to have the sum of all those numbers which lie in A union B union C. For that we require n of A union B union C. N of A plus n of B plus n of C minus n of A intersection B, like that. There is a lengthy formula, of course. We are supposed to decide all of them. First of all, divisible by 3. How many are divisible by 3 from 1 and 100? 3 plus 6 plus 9 and so on, etc. up to 99. Next, divisible by 5. 5 plus 10 plus 15 and so on, etc. up to between 1 and 100 he is saying. Therefore, you are not supposed to take 100. You are supposed to take up to 95 only. 95. The third one, those divisible by 7. How many are they in number? Divisible by 7. What are they? 7 plus 14 plus 21 plus etc. 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 98. Next, divisible by 3 and 5. We know that a particular number is divisible by 2 integers A and B if and only if it is divisible by their LCM. What is the LCM of 3 and 5? 15. Therefore, we have to seek those numbers which are divisible by 15. How many are they in number? What are they? Divisible by 15. That is 15 plus 30 plus 45 plus etc. 90. Up to 90. And then divisible by 5 and 7. What are they? 5 and 7 means must be divisible by 35. How many such numbers are there? Only 2. That is 35 plus 70. 35 plus 70. Only 2. And then 3 and 5, 5 and 7. Now 7 and 3. Divisible by 7 and 3. What are those numbers which are divisible by both 7 and 3? Those which are divisible by the LCM of 7 and 3. What is the LCM of 7 and 3? 21. Those numbers which are divisible by 21. Come on. 21 plus 42 plus 63 plus 84. Stop. At last, those numbers divisible by 3, 5 and 7, their LCM is 105. Below 100 we know we cannot find such numbers at all. Therefore, this is, you observe, this is an AP. How many terms are here? 3, 1 3, 2 3s, 3 3s, etc. etc. 33 3s. So, 33 by 2 into first term plus last term. This is 5, 10, 15 and so on, 95. How many terms are here? 19 terms are here. Isn't it? 1 5, 2 5s, 3 5s, like that, 19 5s. So, the sum is 19 by 2 into 5 plus 95. 5 plus 95. Just like that, this can be 7 plus 14 plus 21 plus etc. up to 98. How many terms are here? 14 sevens are 98. Therefore, 14 terms are here. 14 by 2 into 7 plus 98. I have made use of the formula of sum to n terms of an arithmetic progression, because all these are arithmetic progressions. Just like that, here, how many terms are here? 115, 215s, 315s, like that, 615. 6 terms are there. 6 by 2 into 15 plus 90. Here, only 2 terms are there. This is the total comes to be 105. Here, 4 terms are here. What is the sum to these 4 terms? 4 by 2 into 21 plus 84. Now, what is to be done? The required sum is this plus this plus this minus this minus this. That is, by using n of A union B union C is equal to n of A plus n of B minus n of A intersection B minus n of A intersection B minus n of B intersection C minus n of C intersection A. Of course, this formula gives us the way to find the number of such numbers, and here we like to have their sum. Therefore, this sum plus this sum plus this sum minus minus minus. If you can calculate, that comes around 2838. Hence, the right option is the first option, that is option A, and the right answer is 2838 is the answer for the present question. The next question is question number 17. There were 2 women participating in a chess tournament. Every participant played 2 games with the other participant. The number of games that the men played between themselves proved to exceed by 66 the number of games that the men played with the women. The number of participants is. It's a beautiful question. In order to understand the question, let us first of all know the pattern of conducting the matches or games in such tournaments. Suppose there are n participants. Suppose each player is supposed to play one match with the other among the remaining. Then what is the number of games n persons are there. In order to conduct a game, you have to have 2 persons before you. Therefore, the number of ways of choosing 2 players from n players is nc2. Therefore, the total number of games is nc2. We now use that concept here. In the present problem, some men and 2 women are participating in the chess tournament. Let us first assume that the number of men participating be n. Then let there be n men. How many matches will be there among themselves? That is among men only. N men are there. In order to conduct a game, you have to have 2 persons. So, if one person is supposed to play one match with the other, then what is the total number of matches? nc2 is the total number of matches. But in the present problem, the restriction is every participant played 2 games with the other. Therefore, total number of matches conducted among men, among themselves only, is 2 into nc2. Okay, next one. The number of games that the men played between themselves is proved to exceed 66 by the number of games that the men played with the women. There is another restriction. How many women are there? 2. How many men are there? N. Let the 2 women be, say, A and B. A can participate in how many matches with the men participant? 1 woman, n men. N matches will be there. Just like that, B is a participant in n matches with the men. Therefore, all those men can play 2n matches with these 2 women, provided if there is 1 match. But according to the rules and regulations of the problem, each participant should play 2 matches. Therefore, what is the number of matches or number of games that men played with the 2 women? It is nothing but 2 into 2n. Why is it 2 into 2n? These 2 women can be participants in 2n games with the men. If there is 1 match, but there are 2 matches, therefore 2 into 2n. And according to the problem, the difference is supposed to be 66. The difference is supposed to be 66. The number of games that the men played between themselves proved to exceed 66. The number of games that the men played with the women. Then we want to have the number of participants. Let us see. 2 into nc2 is 2 into n into n minus 1 by 2 minus 4n is equal to 66. Then n square minus n minus 4n is equal to 66. This is n square minus 5n is equal to 66. Therefore, n into n minus 5 is equal to 11 into 11 minus 5. You can observe what is 11 minus 5? 6. 11 6 66. By the simple observation, you will be in a position to say that n is equal to 11. Isn't it? Therefore, what is the total number of men participants in the tournament? 11. We are not supposed to have men. We are supposed to have the total number of participants in the tournament. There are 11 men and 2 women. Therefore, total number is number of men plus number of women. How many are they in number? 13. What is the total number of participants in the game? It is 13. Therefore, among the available options, option C is the correct answer and the correct option. That is 13. Let us look at the next question. That is question number 18. The number of ways in which a committee of 3 men and 4 men be chosen from 8 women and 7 men. If Mr. X refuses to serve on a committee, if Mr. Y is a member of the committee. Mr. Y is a member of the committee. A peculiar restriction on men. The options given are, the first option is 420, second option is 840, third option is 1540, fourth option is 1400. Let us examine which option is correct. Woman, men, present, required. How many women are present? Actually, 8 women are present and 7 men are present. How many are required in the committee? 3 women are required and 4 men are to be chosen. This is the problem. What is the restriction? Is it put on men or women? On men. There are 2 particular men, Mr. X and Mr. Y. Mr. X says, if Y is a member in the committee, I do not like to work with that committee. He might have certain complaint on against Y. We don't know about that. What does he like to say? If Mr. Y is in a committee, I do not like to work with that committee. This is the opinion of Mr. X. Well, we are the persons to decide the committee. Now, we split it into 2 cases. The situation, let us discuss it in 2 cases. Committees with Y. How many? Among 6 men, Mr. Y is selected. You assume, because we like to count the number of committees with Y as a member in the committee. So one person is selected. So 6 men are there. Out of those 6 men, Mr. X is also present. Mr. X is also present. X says, if Y is a member in the committee, I do not work with that committee. Therefore, out of 7 men, Y is already selected. X is not to be selected. Therefore, 5 men are only remained. From those 5 men, how many men are to be selected now? Only 3. Why? Because Mr. Y has already been selected. Therefore, how can you do that? 5C 3 ways. And there is no restriction on women. You can choose 3 women from 8 women in 8C 3 ways. Therefore, this is the number of ways. Now, let us deal with the case without Y. That is, in this case, we do not like to consider Mr. Y to be a member of the committee. So the remaining 6 men only we are supposed to have the committee. From the remaining 6 only you are supposed to choose 4 men. Therefore, it can be done in 6C 4 ways. As usual, it can be in 8C 3 ways. Therefore, what is the total number of committees? This is nothing but this plus this, that is 8C 3 into 5C 3 plus 6C 4. 5C 3 plus 6C 4. What is 5C 3? 10. What is 6C 4? Nothing but 6C 2, that is 15. What is 8C 3? 56. So this is 56 into 10 plus 15. That is 56 into 25. 56 into 25. How many 4s are here? 14 4s are here. 14, that is 1400. What is the answer for this question? 1400, that is the 4th option, that is option D is the right answer. Therefore, we could have arrived at the correct conclusion. because we are able to split the situation into two different cases. What are the cases? How many committees are there if we like to introduce Y in the committee? And again, how many committees would be there if we like to omit Y from the selection? You add all those, total number of committees will be 1400. Therefore, the correct answer, that is fourth option, is the right answer. That is question number 19. The number of different ways in which 8 persons can stand in a row, so that between two particular persons A and B, there are always 2 persons. There are 8 persons in total. Out of those 8, 2 particular persons are there. 2 particular persons are there. Between these 2 particular persons, there must be 2 persons. There are always 2 persons between A and B. How many ways you can arrange all those 8 persons in a row? Okay, let us first attend to the restriction put on A and B. Okay, A and B. How many persons must be there between A and B? 2 persons. What is the total number of persons? 8. Out of those 8, A and B are already there, particular persons. Excluding A and B, how many persons are remained? 6 persons are remained. Out of those 6 persons, how many persons are supposed to stay here? 2 persons. Out of 6, you can arrange 2 between A and B in how many ways? 6p2 ways. Now you consider this as a block. These 2 persons can be arranged in 6p2 ways, and A and B internally can be interchanged in 2 factorial ways. Altogether, this box can be prepared in 6p2 into 2 factorial ways. 6p2 into 2 factorial ways. That is, what is 6p2? 6 into 5, that is 30. 30 into 2. 30 into 2 factorial is 2, that is 60 ways. This is the number of ways of preparing that block. Now you consider this entire block to be 1 person only. Of course, in this block there are 4 persons, remaining persons are 4 again. Those 4 persons, and we are considering this block to be 1 person only. So total, how many persons are there? 5 persons. So this box plus remaining 4. Who can you arrange? 5 factorial. This is the first activity and this is the second activity. Therefore, the answer is 60 into 5 factorial. What is the right option? Option A, 60 into 5 factorial is the correct answer for this question. Therefore, the key part lies here. You keep the restriction given in the problem in your mind. A and B must be there, and between A and B, 2 persons are to be arranged among the from the remaining 6 persons. It can be done in 6p2 ways. Entirely the block can be manufactured in 60 ways. This block, considering this to be 1 particular person plus remaining 4 persons, can be arranged in 5 factorial ways in a row. Therefore, the total number of arrangements becomes 60. 60 into 5 factorial is the right answer. That is option A is the correct answer. Let us look at the next question, that is question number 20. 20 persons are to be seated around a circular table. Out of these 20, 2 are brothers. Then number of such circular arrangements in which there will be at least 3 persons between the brothers is. There must be at least 3 persons or exactly 3 persons? At least 3 persons there must be. Moreover, are they linear arrangements or circular arrangements? They are circular. This is to be thought of with a special intention and special attention also. How many persons are there? 20 persons are there. Out of them, how many brothers are there? 2 brothers are there. You leave one brother at a side in the beginning. What is the total number of remaining persons? 19 persons are there. 19 persons are there, and among those 19 persons, the particular brother A is also present. Let us call those 2 brothers, say A and B. I am first of all excluding B in the beginning. So, in the remaining 19, A is also included. Those 19 persons in a circle can be arranged in 19 minus 1 factorial ways. There is 18 factorial ways around a circle. Around a circle. How many persons? 19 persons. 1, 2, 3, 4, 5, 6, like that. Like that. 7, some 19 places. Between these 19 persons, how many gaps will be there? 19 gaps will be there. Suppose among those 19, let this be the person A. One among the 2 brothers. Now, this is now the time for us to arrange the second brother B. If you arrange B here, there is only one person. If you arrange B here, only one person. Here, 3 persons. Here, 4 persons. Here, 5 persons, like that between A and B. Therefore, to arrange B, let us choose the places which are suitable. You have to leave 1, 2, 3 places to the right and 1, 2, 3 places to the left also. Then only you can see and say that there are at least 3 persons between the brothers A and B. What is the total number of gaps? 19 gaps are there. How many gaps you are supposed to leave? 3 in this direction, 3 in this direction. How many? 6 gaps you may have to leave. So, what is the total number of suitable places for B to be arranged? In the 19 minus 6 places. 19 minus 6 places. What is 19 minus 6? 13. So, he can be arranged in 13 ways. Therefore, the total answer is 13 into 18 factorial. 13 into 18 factorial. You please observe carefully. There are 2 particular brothers A and B. You first include brother A, exclude B at a side in the beginning. So all the 19 persons including A can be arranged in 18 factorial around a circle. I am not represented all the gaps. It is very easy to represent the gaps. How many gaps will be there between them? 19 gaps will be there. 19 gaps will be there. Well, let us decide the place at which the second brother can be arranged. You are supposed to leave 3 gaps to this side and 3 gaps to this side. Total 6 gaps you have to leave, because to maintain the constraint that there must be at least 3 persons between the brothers A and B, you have to leave these 6 gaps. So, remaining 19 minus 6 gaps are only possible for B being arranged. Therefore, the total number of ways is 13 into 18 factorial. That is third option. Option C is the right option. Correct answer is 13 into 18 factorial. Another beautiful question is before us. That is question number 21. The next question. There are 10 stations on a circular path. Quite interesting. A train has to stop at 3 stations such that no 2 stations are adjacent. The number of such selections must be. How many stations are there in the circular path? 10 stations are there. Let me name them S1, S2, S3, S4, etc., S10. Or simply 1, 2, 3, 4, 5, 6, etc., 10. How many stations are there? 10 stations are there. Okay, what is the given options? What are the right given options? First option 50, second option 84, third option 126, fourth option none. Let us examine which option is the right option. The train is to stop at 3 stations. Okay, total number of stations is 10. And the number of ways of choosing 3 stations at which the train is supposed to stop is 10C3. So, total number of selections 10C3. Is it the required number of ways? No. We could not attend the restriction given. What is the restriction given? No 2 of the stations must be adjacent. How many stations you have selected? 3 stations you have selected. How many cases will be there in the selection? 3 stations might be adjacent and 2 stations might be adjacent. Such selections are to be avoided. Such selections are invalid. Now, let us first find the number of those invalid selections. What are those invalid selections? Number 1, selection of 3 consecutive stations. 3 stations are adjacent. In how many? You may take 1, 2, 3, 2, 3, 4, 3, 4, 5, 4, 5, 6, 5, 6, 7, 6, 7, 8, 7, 8, 9, 8, 9, 10, 9, 10, 1, 10, 1, 2. So how many such selections are possible? 10 selections are possible. You don't forget it. These 10 are invalid selections. Again, 2 stations are adjacent. How many? How many stations are there? 10 stations are there. We are planning to find the number of invalid selections, and in those invalid selections we could have already noticed that those selections in which the 3 stations are adjacent we could have already found. In the second case, 2 stations might be adjacent. How can they be estimated? Suppose we have chosen station 1 and station 2. Station 1 and station 2. The third station, it should not be 3 and it should not be 10 also. Otherwise, 3 stations would be adjacent and which we could have already found. Therefore, with 1 consecutive pair, that is 1, 2, you must leave 3, you must leave 10. Out of those 10, we are leaving 4, that is the pair 1, 2, 10, 3. So remaining 6 only you have to choose. That is 1, 2, 4, 1, 2, 5, 1, 2, 6. Like that, how many such triplets will be there? 6 triplets will be there. So with 1, 2, 6 possibilities are there. With 2, 3, 6 possibilities are there. Like that, 9, 10, 1, 6 possibilities are there. If you can count all these, how many? 10 into 6, that is 60. Are these to be avoided or included? These are to be avoided because these are all invalid selections. Let us now count the total number of invalid selections. These are 10 in number, these are 60 in number. 10 plus 60, how much? 70. Therefore, answer will be total number of selections 10C3 minus invalid selections 10 plus 60. What is 10C3? 10 into 9 into 8 by 3 factorial, that is 6, minus 70. Minus 70. If this is 72, goes 12 times, 120. 120 minus 70 is nothing but 50. Therefore, the total number of ways of choosing 3 stations such that no 2 stations are adjacent is 50. That is option A is the correct answer for this question. Option A, that is 50, the total number of selections is 50, is the right answer. Another beautiful question is before us. That is the next question. Question number 22. Let n and k be positive integers. Okay, n and k are natural numbers such that n is greater than or equal to k into k plus 1 by 2. N is greater than or equal, not less than k into k plus 1 by 2. The number of solutions of x1, x2, x3, etc. xk with x1 greater than or equal to 1, x2 greater than or equal to 2, x3 greater than or equal to 3, like that, etc. etc. xk greater than or equal to k are all integers satisfying x1 plus x2 plus x3 plus etc. xn is equal to n is. Of course, he has given a separate information that m is equal to 2n minus k square plus k minus 2 by 2. Why? Because among the options, he could have made use of the letter m. First option is mck, second option is m minus 1 ck, third option is mck minus 1, fourth option is 0. Let us see what happens. You see, what is the restriction given on the variables? x1 is greater than or equal to 1, x2 is greater than or equal to 2, x3 is greater than or equal to 3, x1 is greater than or equal to 1, x2 is greater than or equal to 2, x3 is greater than or equal to 3. Like that, if you proceed, xk is greater than or equal to k. Now, let me have a suitable plan to find a solution for that. Let me take y1 is equal to x1 minus 1 greater than or equal to 0. Got it? x1 is greater than or equal to 1. So, x1 minus 1 is greater than or equal to 0. Just like that, y2 is equal to x2 minus 2 greater than or equal to 0. y3 is equal to x3 minus 3 greater than or equal to 0. y3 is equal to x3 minus 3 greater than or equal to 0. y4 is equal to x4 minus 4 greater than or equal to 0. And you proceed like that. yk is equal to xk minus k, which is again greater than or equal to 0. Well, let us add all these things. What happens? y1 plus y2 plus y3 plus etc. yk, that is the left hand side, y1 plus y2 plus y3 plus etc. yk is equal to x1 plus x2 plus x3 plus x4 etc. xk, x1 plus x2 plus x3 plus etc. xk minus 1, 2, 3 etc. k. 1 plus 2 plus 3 plus etc. k. It can be summed as k into k plus 1 by 2. K into k plus 1 by 2. But in the problem, it has been given that x1 plus x2 plus etc. xn is n. Hence, we can take it as n minus k into k plus 1 by 2. K into k plus 1 by 2. Good. Therefore, in the actual question, we need to have the number of solutions of x1, x2, x3, etc. xk plus the sum of those is n. And now, we want to have the solutions of y1 plus y2 plus y3 plus etc. yk is equal to this. Moreover, as the given x1, x2 etc. are all integers, 1, 2, 3 etc. are also integers, hence y1, y2, y3 etc. yk are also integers. Which type of integers? Greater than or equal to 0, greater than or equal to 0, greater than or equal to 0. Are equal to 0. Therefore, the actual number of solutions is the number of non-negative solutions of y1 plus y2 plus etc. yk is equal to n minus this. And We could have had a beautiful formula for that. Let me call this entire thing some lambda. So the answer is lambda plus k minus 1 c k minus 1. C k minus 1. What I mean to say is, I like to take this entire thing some lambda. Some lambda. So ultimately, what is required at the end? We want to have the total number of non-zero solutions of non-negative integral solutions of y1 plus y2 plus y3 etc. yk is equal to lambda. Of course, lambda is an integer. What is the answer actually? Lambda plus k minus 1 c k minus 1 is the answer. What is lambda? N minus k into k plus 1 by 2 minus 1 c k minus 1. Let us calculate this number. What is that? LCM is 2. 2n minus k square plus k minus 2 minus, now this is plus, by 2. What is this? 2n plus k square plus k minus plus k minus 2 by 2. You observe this. 2n plus k square plus k minus 2 by 2 is nothing but given m. Given m. Hence it is mck minus 1. You calculate this is nothing but m given. Therefore, the right option is third option, that is option C is the correct option. Without giving this entire thing, he has just given m, and inside the brackets he has given the value of m, of course. That is the answer. Option C is the right answer.